All right, here are solutions for quiz 8 for math 211. What you're first doing is some operations in other bases. So multiply these two numbers using the intermediate algorithm. These numbers are in base 16. What you need to know about base 16 is we need some extra symbols to represent our base 10 concepts of 10, 11, 12, 13, 14, and 15. So kind of our standard is to use the letters A, B, C, D, E, and F respectively. So this will be kind of a little legend that I refer to throughout this problem. When I'm doing the intermediate algorithm, what I do is I take one of these numbers, multiplying it by the other number, and I'm going to show each partial sum. So I'm first going to do 2 times 5. 2 times 5 is 10, and so I can either write 10 here or I could write A here. Actually, no, you'll want to write A here because you'll want your columns to have meaning. So you put an A right here. 2 times 5 equals A. 2 times 3, well, it's not really 2 times 3. It's 2 times 3 is 0. And 2 times 3, 0 would be 6, 0. So I'll write that here. What about 4, 0 times 5? Well, I'd start by putting a 0. And then 4 times 5 I think of as 20. But 20 in base 16 is one group of 16 with 4 left over. So I'll write 1, 4, 0. And that was the 4 times 5. Now I want to do 4, 0 times 3, 0. Well, there's the two zeros. I just have to worry about 4 times 3. 4 times 3 is 12. Which I would write with a C. And then the nice thing about multiplying by 1 is it's really easy. So multiplying by 1, 0, 0 is fairly easy as well. I'll put down the two zeros, and when I'm multiplying times the 5, I can just put a 5 here. And when I'm doing 1, 0, 0 times 3, 0, I'll put down 3 zeros, and then 1 times 3 gives me a 3. And now I got to add all these guys up. A plus a whole bunch of zeros is A. 6 plus 4 is 10, which, as we saw before, is A. 1 plus C plus 5. Okay, that's kind of annoying. C is 12, 13, and 5 more gives me 18. But 18 in base 16 is one group of 16 with 2 left over. And then in my next column, 1 plus 3 gives me 4. I get this number, 42AA. And I guess if you want, you could specify that this is in base 16. Or you could write hex next to it to represent that this is hexadecimal. I don't care what you do. If you get this answer, I'm a happy man. So there's the intermediate algorithm. Note that I have 6 partial sums here. 3 times 2 gives me 6. 1, 2, 3, 4, 5, 6. And all those add together to give me this number. Division. Divide this by this using the standard long division algorithm. What you'll want to do before you would do any division problem in a different base is to multiply the smaller number here, this 1, 3, by each of the one-digit numbers in that base. So 1, 3 times 0 is just 0. I'm going to be lazy and not even write it. 1, 3 times 1 is 1, 3. 1, 3 times 2, you're like, it's 2, 6. No, it's not because I'm in base 4. 2 times 3 is 6, but in base 4, I write that as 2 with one group of 4 with 2 left over. And then 2 times 1 is 2, plus 1 more is 3. I get 3, 2 as this product. 1, 3 times 3, which will be the last one I have to do because it's the largest single-digit number in this base. 3 times 3 gives me 9. 9 I think of as one single with 2 groups of 4. 3 times 1 is 3, plus 2 more gives me 5, which in base 4 I write as 1, 1. Okay, so I have all my products written up here, and that'll be useful when I come down here to do my long division. When I do 1, 3 divided by, I'll try to leave myself lots of room, 1, 0, 1, 0, 2, 3, 0. Looks like I left myself a little too much room, but what are you going to do? I do this division. 1, 3 doesn't go into 1, 0. It's too small, but does it go into 1, 0, 1? Yes, it does. How many times? Well, since I have them written up here, I can see that it goes in exactly 2 times. Because it can't go in 3 times. 3 would be 1, 1, 1, and that would be bigger than 1, 0, 1. So it only goes in 2 times. I'm going to put a 2 up here because I know that 2 times 1, 3 from above is 3, 2. And now I'm going to subtract. When I'm subtracting here, let's see, should I mess up this number? I guess I can mess it up. I can't take 2 away from 1. I don't have enough, so I have to borrow, but there's nothing here to borrow from. So I can reduce this down to a 0. And by doing so, that changes this into a 4. But I can't leave this as a 4 because I had to borrow from this 4, which makes it a 3. It gives me 4 more over here, which I'm going to write as 5, even though I'm in base 4, because now I can do 5 minus 2 to get my 3, and 3 minus 3 gives me 0. So I bring down a 0 if you feel like it, and this is a 0. Now I'm good. And so now I can bring down a 0 and repeat. 3, 0. 1, 3 goes into 3, 0 exactly one time. I know it doesn't go in twice because twice would be 3, 2, and 3, 2 is bigger than 3, 0. So I got to subtract 1, 3. And when I subtract, I borrow here. Let's see, I don't know if this should be in another color or what. I'm not going to write the crossing out things. I'm going to talk through the crossing out parts. So I cross out here. This 3 turns into a 2. This 0 turns into a 4. 4 minus 3 is 1. And 2, which this now is, minus 1 is 1. And then I bring down this 2. So now I need to know how many times 1, 3 goes into 1, 1, 2. Well, it looks like it'll go in 3 times. Because 3 times 1, 3 gives me 1, 1, 1, which is less than 1, 1, 2. So now I can subtract. 1, 1, 2 minus 1, 1, 1, that's pretty easy. It's just 1. And now I'll bring down this 3 here. And figure out how many times 1, 3 goes into 1, 3. Well, it goes in exactly once. 1 times 1, 3 is just 1, 3. I subtract and get a 0. I bring down this 0, ask myself the question, how many times does 1, 3 go into 0? The answer is 0. It's important that I put a 0 here as that placeholder. 0, 0, my remainder is 0. My answer is 21310 base 4. I guess that's all I have on this one, so let's move on to this guy. Determine if this ridiculous number, determine if this, the following number, that makes no sense. Determine if this number is divisible by each of the following using our divisibility tricks. Divisible by 9, question mark? No. Well, maybe. Let's sum the digits. Sum of digits is, see, 1, 2, 3, 4, 5. There's 10, so I'm up to 15, and 6 more gives me 21. Sum of the digits is 21. 21 is not divisible by 9. So neither is this number. What about divisible by 4? Well, for divisibility by 4, I just have to look at the last 2 digits and the number that's made up by them, 26. 26 is not divisible by 4 because 6 times 4 is 24 and 7 times 4 is 28. 26 not divisible by 4, so neither is the number. Divisible by 11. So for 11, I need to sum every other digit. So this guy, oh, this is going to be obnoxious. This guy, 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 that guy, and that guy. If I sum up all those numbers, I think I have a 1, a whole bunch of zeros, a 2, so I'm up to 3 now, and 2 more gives me 5. And then if I sum all the numbers that were not underlined, or overlined, I guess, that, this, this, that, and that. What do I get? Whole bunch of zeros. There's 1, 2, now I'm up to 10, and 6 more gives me 16. And 5 minus 16 equal, maybe I'll leave it like that. Let's write it down here. Sums of alternating digits are 16 and 5. Those were the 2 that I wrote up here. 16 minus 5 equals 11, and 11 is a multiple of 11. Thus, the number is divisible by 11. What about 24? To check 24, I don't have a trick for 24, but I can check other tricks. I have an 8 trick and a 3 trick. Because 3 and 8 are relatively prime, I can test 24 by testing 3 and 8. So first let's test for 3. 3, sum of the digits was, we already did that, was 21? 21. Sum of digits is 21. 3 divides 21. So 3 divides the number. What about 8? For 8, look at the last 3 digits in that number. So in this case, 826. 826 is not divisible by 8. The reason I know that is 800 is, so really I just have to check is 26. 8 times 3 is 24. I want 26. So 8 doesn't go evenly into 826. 826 is not divisible by 8, so neither is the number. I can say that. To pass, so in order to pass the 24 test, it has to pass both the 3 and the 8 test. It did not pass both of those. So kind of doesn't pass 24 test, aka not divisible. And that ends the quiz, so I'll stop the video here.